two concentric circular coils X and Y of radii 16 cm and 10 cm lie in the same vertical plane containing north to south direction. The coil X has 20 turns and carries a current of 16 ampere. The coil Y has 25 turns and carries a current of 18 ampere. The sense of current in X is anticlockwise and in Y it is clockwise. For an observer facing west, give the magnitude and direction of net magnetic field at the center. So that is the question. Let's take one coil at a time. That's what I'm going to do for the solution. So for coil X, I'm going to just write the given data for the coil X. So what are the given quantities? That is, I will take it as, first thing given is radius. So I'm going to take it as R1 equals 0.16 meter in the data of X. So N1 is given as 20 turns and the current I1, I will take it as, it is 16 ampere. Put it back anti-clockwise. Now we are going to find the magnetic field of X. I will call it as Bx. That is the magnetic field of X. And also we have seen the equation. It was mu naught by 4 pi 2 pi Ni divided by R. This is N1, I1 and R1. So those are the things I need to mention here. Now substituting the values for the X coil. So this mu naught by 4 pi, it is going to be 10 to the power of minus 7 into 2 into 3.14, that is for the pi, into N1 is 20, into I1, that is the current, it is going to be 16 ampere, and the whole thing is divided by radius R1, that is 0.16. So this is 0.16 and this is 16, so this is going to become 100. Then it is going to be 2 into 2 into 100, 2 into 20 into 100, and I am going to keep that pi as it is for now. If you want, we can just write the value. So it will be 2 into 20, that is going to give me 40. I am going to drop that 0, so it is just going to be 2 into 2, 4, 4 into 3.14, that is going to give me 12.56. Now dealing with the powers. There is a 10 to the power of minus 7. I had to drop this 0 from that 20, so it is going to add one thing, so it is going to become 10 to the power of minus 6. Then two more zeros are available with us, so it is going to become 10 to the power of minus 4. So into 10 to the power of minus 4, that is the magnetic field of X. So that is this thing. This is one way of dealing with the things. Or alternatively, one of the book, it is given the solution without mentioning the value, without taking into account the value of that pi. So instead of writing that 3.14, what they have done is they have just kept that as pi. So what we are going to be left with here is, instead of Bx mentioned in this way, they have mentioned Bx equals 4 pi into 10 to the power of minus 4. So the same thing, but instead of solving for pi, they have kept that pi as it is. We will go for the y part for point Y. So radius, I'm going to take as R2, it is 10 centimeter, so it will be 0.1 meter. Then the next thing is, I need the current. Y has 25 turns, so it will be N2 equal to 25. Then there is current. I2 is 18 ampere. Then, and this clockwise. So this is going to be By. It will be again mu naught by 4 pi into 2 pi N2 I2 divided by R2. I'm going to do the substitution right in there in front of it. So it is going to be 10 to the power of minus 7 for this mu naught by 4 pi into 2 into pi. I can write it as 6.28. 2 into 3.14, it is going to give me 3.28 into N2 is 25 and I2 is 18. I hope it is visible. Yeah, it is visible. And the whole thing is divided by the radius R2, and that R2 is 0.1. Pi, which I am writing in this way, it is going to be 9 pi into 10 to the power of minus 4 and 0.26 into 10 to the power of minus 4 tesla. So this is the value of By. So both ways the answer is available with you. So we have the value of Bx, we have the value of By directly, and also we have them in terms of 4 pi and 9 pi. Now what we need to calculate? We need to calculate the magnitude and direction of net magnetic field at the center. Now it is very simple. We just need to calculate the B. What is B? We know that By is a much bigger number compared to Bx. So what I'm going to do here is it will be By minus Bx 7. So 28.26 minus 12.56. I will take the power common into 10 to the power of minus 4, and this B is going to be 15.7 into 10 to the power of minus 4 Tesla. So that is the magnitude. And similarly, if I solve for this one, that is Bx and By, I'll finish it off here. So Bx, B is equal to By minus Bx. This was equal to 9 pi minus 4 pi into 10 to the power of minus 4 is common. So this is going to give me 5 pi into 10 to the power of minus 4. And if I substitute the value of 5 pi here, it is going to give me 5 into 3.14. That is going to again going to give me 15.7 into 10 to the power of minus 4 Tesla. So both ways we are going to get the same answer. So if it is clockwise, this was the plane of the coil. The observer was facing the west direction. The anti-clockwise current in X is going to be producing a field which is going to be facing the east direction, and the clockwise current in the coil Y, it is going to produce a magnetic field which is going to be like this. So it is going to be towards west. So X is going to produce a field which is going east, and Y is going to produce a field which is going west, and we know that the Y value is larger, so that is going to be dominating. So the answer for the direction is towards west. So the net magnetic field is going to be 15.7 into 10 to the power of minus 4 towards west.